So I'm on my way down to the church. I've taken a few weeks off to kind of get caught up at work, but it kind of dawned on me that I haven't really done a full walkthrough and video of how everything is set up. So as soon as I get down there, I'll kind of take you through all of the construction, the setup, the wiring, the routing, and all that. But something I did want to kind of address when I'm talking with people who are traditional sound engineers. I think they lose some of the point of the original wall. If you ask any musician, a guitarist, particularly, where their tone comes from, they're going to tell you it comes from everything. It's going to come from my fingers, my guitar strings, my guitar, my preamp, my amplifier, my speaker. And at that point, that's where traditionally the PA would take over. You would mic that speaker, so all of those things that come into play create the guitarist's tone, and then you want to try to replicate that through the PA as flat as possible so that you're not changing what their tone is, their signature is. The wall is different in that because it's not a traditional PA, the wall itself is part of that kind of tone chain. That is the final step. So you're not trying to take what the guitarist is doing and replicate it perfectly flat. You're using the wall to create some of that tone as well. And that was, I think, a big thing for them was they are now one with this PA system as part of their signal chain. So, what you'll see when I start walking through what I've created is that it's somewhat of a hybrid where it can be used that way or it can be used more like a traditional PA. But anyway, I mean, that was a big part of the wall. It wasn't just that everyone had their own channel, it's that it wasn't a traditional PA system, and that you'll see as we start kind of walking through that in a few minutes. So down at the church now, and we'll start kind of walking through how I've got everything set up here. Um, it's cold in here, so it's probably, I don't know, 40 degrees. It's almost the beginning of February, and the place does not exactly have it has no heat. So unless I'm firing up the Canon heaters, it's just going to be cold in here. But we'll kind of walk through the signal chain of everything. So I'm going to just flip around here. So a couple things to note here. We'll talk about just scaffolding in general. When putting this thing together, using full-size scaffolding wasn't really an option because it would look mammoth, given the smaller scale. So, most of the scaffolding here is actually, handmade by me and a couple other people, all using 3/4 inch EMT electrical conduit and connectors. So it's, it's surprisingly strong. It can hold my weight without a problem for setup, but I would certainly never have anyone else climb on this stuff. Contrary to popular belief, the scaffolding really did not serve a purpose in the original wall of holding it up as much as it was they needed a method to be able to climb up there and stack all these speakers. Everything here is, basically shimmed and balanced, supporting its own weight. And if you look up close at all the cabinets, I mean, you'll see that not every cabinet is 100% perfectly square, and if it's out by a 32nd of an inch, add up 18 speakers high, and you could be leaning inches in any direction. So it was important kind of setting it up that you shim as you go to keep everything nice and plumb and level. And then the scaffolding becomes just a means of getting up there, and then you can, in a few places, kind of tie things off to kind of stabilize things and make sure there's no real, emergencies. As you can see here, I mean, it's certainly holding the weight of, we've got 8 2x12s and this array of 54, 3-inch speakers. This is, several hundred pounds on there now. The main exception to that would be the center vocal array. It weighs 700 plus pounds, and that could not be done with EMT scaffolding. So when we designed this, I had to kind of engineer what size steel to use up top to hang this thing from so that it can support 5 or 6 times the actual weight that's being suspended. So I've got a 2.5-inch by 1/4-inch steel square tube running in 4 different locations so that the load is all transferred down to the main columns here, right down to the ground. So we're certainly good for 5 times what we're suspending there. And then the 3 chain hoists I think they're good for 2 tons each. So I think we're probably over-engineered, but that's kind of it's necessary. You don't want to be the drummer underneath this thing if you've just kind of taken it right to the limit. So we'll start, taking a look at the actual power first. This wall has a lot of amplifiers that draw a lot of power. So when we came into this space, there were literally 420-volt receptacles in the whole room. So we put in see over here, we put in a 50 volt 204, or sorry, 50 amp 240 volt box and a 30 amp 240 volt box. And for a temporary power solution, we're using a series of kind of homemade distros. I've got one here that's good for 30 or 50 amps. And then behind the wall, I have another 240 volt 50 amp, basically just an entire electrical panel back here dedicated just to this wall. So all told, I think we have 80 amps, 240 volts that power this whole thing. And we've yet to, trip a breaker on anything. So, it seems to be sufficient. So as far as the instruments go, we'll start over here on the left. So what I have here would be, I've tried to locate the amplifiers close to their speaker columns versus close to just what instrument it's tied into. So the first rack, the first amp is controlling both the Jerry and the Bobby stacks of speakers. So these are all, Class D amplifiers. They're 4-channel in this case for Bobby and Jerry, that when bridged, they're 5,000 watts each at 8 ohms. So certainly plenty enough power. So what happens is everyone is essentially going direct to the console or the board, and then being routed to their speakers. So in this case, you'll see I've got a couple Quilter heads up here. Musicians can plug into that. Guitarists can bring their own preamps. They can really bring anything they want, but the ultimate goal is that they have to go direct into the console. So they would plug into their amp, or the Quilter in this case, come out of that. They're going to go into a little patch panel down here. That patch panel is going to route all the way over to the main rack. You'll see I have a Midas 40-channel digital mixer up top and a digital snake down below. So basically, the guitar is sending their signal from their preamp over to the board, to the patch panel here. It's then being routed digitally, which I'll show you in a little while, basically right back to this cab, to its amp, and then from that amp, it's going back to its speakers. Which, if we go back around here, we'll use Jerry's speakers as an example. So all of these speakers here, going all the way up on the far right, those would be all the Jerry speakers. And there are 26-inch speakers, 130 watts continuous each. And some of you probably are noticing they're all wired in parallel, which normally would be a no-no, because you're looking at 0.2 ohms or something when you finally get all this done. And that's where these 0 ohms come in, which have so far proved to be a really great product. So when I come out of the amp, I'm going direct into this Z ohms unit. And this is a passive unit that will take that signal, the power, the amplified signal, and if the speakers are all the way down to 0.3 ohms, or essentially right down to 0 ohms, it'll basically tell the amp you're seeing 8 ohms. It doesn't seem to add any color to the sound at all. It seems to do nothing more than make it an 8 ohm signal that the amps can tolerate. So it makes configuring the system really easy, in the sense that I can just stack up all of these speakers, not worry about doing any math as I used to have to do. And it's great because if you wanted to remove one, if you blew a speaker, you didn't have to recalculate anything. If you wanted to add more for a larger venue, you could do that. So it definitely simplifies things quite a bit. So basically, when the guitarist plugs in, they have 100% control over their tone, right from their guitar, through their preamp, through their amp, through the Z ohms, right to their speakers. And the only purpose of having this console over here, the digital mixer, is for routing signals back here. The beauty of that is that if you, let's say you have a band playing that's only got 3 musicians, well, you could say instead of just having the guitar player play here, maybe there's just one guitar player. Well, now they can come out of this column, and they can also come out of what would have been the rhythm guitars column. So that's the general signal path for how it would work for instruments like the guitars. So looking at the wall, we've got Jerry's column here, and then over here I've got Bobby's column, which is the same thing. These are 2x12s, 2x6s that are all wired in parallel again. The difference being is Jerry had open back cabinets, as you saw, and the Bobby cabinets are closed back but front ported, and they do sound quite a bit different. So if we kind of want to follow this through channels, Phil will do next. So Phil has the tallest columns. They are 18 1x8s in my case. They would have been 1x15s. So you have 18 speakers on this side, and then on the other side of the wall, you've got another 18 1x8s. Okay, all of these speakers are Bema. I believe they are 8WR300s. They're 300 watt 8-inch speakers with aluminum baskets. These 36 speakers are actually broken down into 4 channels. So you've got the bottom 9 and the top 9 on both sides are each their own channels. So that when Phil was using Mission Control or Osiris, whatever you want to call it, he was actually getting quad bass where each string would be mapped to an individual 9 speakers. I don't think it was used that often, maybe for some spacey jams and for some stuff with Ned, but for the most part, as I'm doing right now, everything was running in mono. So if we come over here to the Phil side, I'm using this this great little TC Electronics amp for now, just as a head. It actually does a remarkable job for getting fill tones, and it has a direct out, which makes it easy to use. But you could certainly run Alembic F2Bs, whatever type of preamp you want. And then down here, we can run all 4 bass channels into the patch panel. All 4 of them are going to go back to the main digital snake, to the mixer, and it's going to send it right back here to my 4 bass channels. So each of those bass channels is 5,200 watts that feed 9 different 8-inch speakers. So that's the basics of how the fill side of things work. Most of those instruments are pretty easy to deal with because they're single instruments and single speakers. Where it starts getting more complicated is when you get into the drums, the vocals, and the keys. So we'll look at the keys first. They're fairly straightforward. So I've allotted for 3 or 4 different inputs for keyboards into the patch bay down here, and all of those tie into these speakers here. So this whole section on the far right is just for keys. On the far right, you've got the 8-inch. I've got 14 8-inch speakers that just handle the keyboard lows. All the mids are handled by these 16 6-inch speakers, and then you've got actually 16. I got 22 6-inch speakers, and then 54 of these 3-inch speakers for the high end. So in the keyboard case, everyone routes again. You're going to go direct from your keyboard through whatever DI box or whatever method you need to get it into the patch bay here. Goes over to the mixer, and it sends it back from the mixer. Instead of going right back to the amps in this case, because we've got different size speakers for different frequencies, we've got to go through some digital crossovers. So I have one set up for the keyboards here, and that separates it out. Sorry, my gimbal's going a little crazy here. That separates it out, so I've got my highs, mids, and lows broken down. So they're coming in with a single signal. Lows are going over to the right, mids are going up top here, and then down here we've got all of our highs. So that's how we handle all that with the keys. And I'm still monkeying around with what the crossover points are for that. But everything is kind of centralized to where the keyboards are, so they can adjust their own amp volumes if they needed to. But for the most part, we try to lock everything before they start playing. The 0-ohm system is being used for every column that is individual cabinets. So if you see a speaker here that has you know, one speaker in it or two speakers in it, anything but these larger arrays, they're all just single speakers wired in parallel using the 0 ohm system. When we get to these larger arrays where you've got 50 something speakers, for those I've wired them in series parallel just because they're fixed. I'm not going to be moving them around or changing them. So these 54 speakers are wired in series parallel, and I think they're somewhere around 4 ohms for that particular array that's broken into several channels. So that's it for how the keyboards are laid out. Drums are another fun one. I've accounted for 2 drum kits, even though there was only 1 drum kit. We can do, I think, boy, maybe there's 16 channels dedicated for drums. So, it works sort of the same way. Every one of the drums is going to run their mics into the main console, into the digital snake here. They're then going to go from the mixer, the console, into the digital crossover. That's going to separate out highs, mids, and lows. And then from there, they're going to go into a splitter down below so that we can then split that signal into left and right. And I'll show you exactly why we need to do that. The drums are handled by a couple different things. You've got an entire tall column of 8-inch speakers that are just a kick drum. So that's the channel in and of itself. It's not mixed in with the other channels at all. So kick drum is completely dedicated to 16 8-inch speakers. Then when you come over here, all of these cabinets here are actually for the drum mids and highs. So the top 5 of these 8 cabinets, each one has two 6-inch. They are Fital Pro FE200s, I believe. So each of those speakers, and then 5 Fital Pro 3FE25s. Even though I've got 5, 6, 7 speakers in each cabinet, I've actually wired up the cabinets so that there's actually 2 totally separate arrays in there. So all of those 3-inch speakers in that entire column are one column wired in parallel, and all of the 6-inch speakers are their own column wired in parallel. And then each of them, again, can go through the Z-ohm system. So from my digital crossover, I can send all my mids to all of the 6-inch speakers and all of my highs to all the 3-inch speakers. And the kick drum then goes to its own channel over here that is, has its own separate amplifier and everything. So, for drums, if you come over to the main panel, you'll see I've got it broken down where, let's see, I've got my drums high right, my drums high left. I've got, let's see, drums mids right, and I've got, actually that's for my drums mids in general. And then over here, I've got a separate bridge channel for the kick drum alone. So that takes care of our drums. For vocals, this is also a fun one. So for vocals, we're not using the dual mics. I've been playing around with trying to kind of re-engineer that just almost for fun, but what I'm using are these OptiGates here. So they are just simply, they're optical noise gates to mitigate some of the feedback. So what happens is there's a infrared sensor on the front of it. So when you get within a couple inches of it, the green light goes on, and the red light goes on, you're live and you're active and you can sing. Once you back away from it more than 2 or 3 inches, it kills the mic, or at least cuts 16 decibels out of it, so you're not getting all the feedback, having all the speakers kind of in front of the microphone. So far, those OptiGates have worked great where I haven't needed to do anything else. So every mic, I'm using OptiGates. And, it takes a little while to get used to it because you can't, when you sing, you've got to get used to kind of, you got to approach that mic dead on. If you are one of those sideways singers, you may not be triggering the mic. If you're doing a Bob Weir where you're pulling up to the mic and then screaming and backing off, your signal may cut out from you. So, you can kind of go back and look at some of these wall videos and see that even they had to kind of adapt how they were singing and using them. So from there, all of our vocal channels, they're split up to stage left and right. So some of the mics are going to go into the patch panel down here. Some of them are going to go into the patch panel right into the digital snake over here. And some of those mics are going to go over into the patch bay over here. All of them are going to go into the mixer, and all of the vocals are mixed down into a single channel. So that's done at the console. And then all of those again come to the console. From there, they're going to go to a crossover. They're going to go through a splitter so that I can split my left and right vocals to these speakers here. These bottom three kind of combo cabinets are vocal fill speakers, not so much for the audience, but for the musicians, because think about it in the real wall of sound. The vocal array is 9 feet or so off the ground. A lot of that sound's going right over your head. So you've got 3 speakers down here just to give you some vocal fill on the left and again on the right. So the splitters just simply break that mono signal into a left-right. Within that, of course, we've got highs, mids, and lows. So vocals have an entire column of 16 8-inch speakers for the vocal lows. Then on the left and right, we've got 6-inch speakers for vocal mids fill. We've got, in this case, 15 3-inch speakers for vocal high fill in. Same thing on the right. And then when we get to really the bulk of the vocals, they're coming out of 66-inch speakers. These are also 6FE 200s, Vital Pros, for the mids. And then above that, I've got 96 3-inch Vital Pro 3FE 200s. And then above, I have, there's 20 some odd horns that those were primarily, honestly, aesthetics in this case, because I've got so many smaller speakers that could handle the high frequencies that I didn't feel I really needed the horns, and I couldn't find any that were that small that suited my purposes. So I bought these cheapo, piezo horns just to have it at least look correct. And as it turns out, the piezo horns actually sounded pretty good. So I kept them in there, and they are all active, except for the ones where you see some sunlight coming through, because the cables behind the that are supporting the center column would be hitting the horns. So anyway, this all those speakers are indeed functional and actually do add something to it. So that's kind of the gist of how the routing works on this side. And then on the mixer side, we come over here and I've got this is a Midas digital mixer. I don't use a physical board. It's just all on the computer because I'm really hoping to, once we start using it, that we're not monkeying around a lot. It's kind of a set it and forget it thing. But you can go in and using the mixer here, you can change, at least if you wanted to change where things were being sent to. I could say for Jerry guitar here, I could come in and say, well, right now we don't have a rhythm guitar, so I'm going to go over to my sends, and I can say, let's send him not just to Jerry's guitar column, but let's maybe come over to Bob's guitar column and send him there, and I could kind of route his signal to multiple channels. So it just gives you some kind of infinite flexibility in terms of how you configure the system. It's not being used like a traditional console where you've got a main left and right. There are no main left and right PA channels at all. I'm using all of these auxiliary outs on the digital snake, so that each column of speakers has its own array, or its own auxiliary output, so you can control everything. And what's interesting is I can go in and fine tune the system either at the musician level. So I can say, for Bob Weir, I can change his EQ, I can change some of the parameters on his things, or I can do nothing here and change it at the actual speaker level. So you can either tune the wall itself, or you can tune what's being input into the wall. And I'm still playing around with which way works better for which things. I think the purpose for me of doing this digitally is I can make the wall much more flexible, and at the same time, I can build in some safeties in there where I'm not blowing up speakers, because there have been a few times where I haven't done that, or I really thought I had done some serious damage. And now with the digital mixer, I can go in and do some work to kind of mitigate that. If we take a walk behind the wall now, it's a little chaotic here because I still have to work on just what the most efficient way to run all this cable is. The back of the racks get pretty hectic, and with cables everywhere, as you can imagine. With the regular wall sound, it would have been more crazy because they weren't doing what I was doing, where everything's simply run in parallel. is a little more complex. So, you can see it's actually pretty neat when you're getting up into the stacks. I've run all my cables here. I'm using on the amplifier side, everything is you can see that on the speaker side, everything is done with banana clips, which a lot of people question why use banana clips. Why not use speak-on cables like the twist lock speak-on cables that I have in the back of the amp? And the wall used banana clips. This massive thing was using these tiny little connectors. Well, they've got great surface area. They do a great job. But what I found really important in my case is when you trip over a cable that has a banana clip, the banana clip snaps off and it doesn't pull 30 speakers down on your head. Whereas if you trip over a cable that's been locked in place, for a wall this size that doesn't weigh as much as the actual wall, it could be disastrous. So, with few exceptions, everything is done using banana clips. Um, you know, this is the back of the main cabinet. That is just more of the brains of the system. The center vocal array I actually broke down into 4 channels for the mids. And you can see I got speak-on connectors for those 4 channels. I have 2 channels for my highs, which are up top there. Everything else over here is, again, wired in parallel using banana clips. This should be a closed back cabinet, but it's open right now because I haven't screwed the back on. But you can just see this is kind of a series parallel wiring for all the 3-inch speakers for the keyboard highs. And then also I started to, had to work with the lighting aspect. I wanted to keep the lighting very simple because there really was not a lot of control in the lights from the wall. And that's always something that was shocking to me. And I think Candace was really restrained in her lighting. In fact, you very rarely see pictures of the lighting from the wall of sound or even the wall at night because I don't know why they didn't do it. It's a little crazy to me. But in my case, it's all analog stuff. I've got a little dimmer pack over here, which I'll see if I can get over there. So I can run all of my lights into this dimmer pack and then control them with a lighting controller on the other side of the room. But it's still very basic. I mean, I just wanted to be able to have light to kind of illuminate the stage area and illuminate the wall itself. But certainly I would need more lights, in a larger venue. As you can see up top, I'm using, regular power cans like the original. They're all dimmable using that dimmer pack. But it just, kind of allows you to at least get a sense for the wall, lit up. If you look at the footage from the outtakes from '74 from the Winterland, where they filmed for the Grateful Dead movie, and it always blows my mind that here they are filming their greatest creation, and there's not a single video showing the wall. It's all like in darkness, which I could never figure out the logic behind that. But anyway, here it is all lit up, and this is kind of gives you a general layout of how the wall is set up and things are routed. Um, when we start moving forward and doing the full scale one, the question then becomes is, do we keep doing things that use some modern technology to make it an improved wall, or do we actually start bringing in Macs and do everything exactly like the original wall was? And time will tell. Some of it will just kind of depend on where the wall is going to go ultimately, and what the venue or owner of a full scale wall would want to have for its purpose. So anyway, ask questions as many as you like. It's 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 always fun to do this, and I learn a lot when people ask questions or offer ideas or things like that. So this is largely a project that has come together because of input from a lot of different people. Anyway, there it is.